Ever wondered about the invisible threads that weave the fabric of our universe? Just as the loom relies on both the warp and the weft to create a beautiful tapestry, our understanding of the cosmos is shaped by two interweaving strands of scientific inquiry: theoretical physics and experimental physics. Each has its unique role, yet both are crucial in our quest to unravel the mysteries of the universe. Today, we're diving into the world of theoretical and experimental physics, two sides of the same coin, but how do they differ? Imagine a world where the laws of nature are mathematical equations. This is the realm of theoretical physics, a fascinating domain where the secrets of the universe are unraveled through the language of mathematics. Welcome to this intellectual endeavor, a journey into the abstract. Theoretical physicists, like master weavers, spin intricate mathematical tapestries that represent the phenomena of the universe. Their tools are not telescopes, microscopes, or particle accelerators, but equations, symbols, and numbers. They play with these mathematical tools to craft models that describe how the universe works. From the quantum realm of particles to the cosmic dance of galaxies, theoretical physics seeks to encapsulate it all. It's like painting a picture of the universe, not with brushes and colors, but with equations and theories. Consider the work of giants like Albert Einstein, whose theory of relativity forever changed our understanding of space and time. Or think about the quantum theories that have given us insight into the baffling world of particles, where the traditional rules of physics seem to turn upside down. But it's not just about developing theories. Theoretical physics also involves predicting new phenomena. For instance, the existence of the Higgs boson, a fundamental particle, was predicted by theoretical physicists nearly half a century before its experimental discovery. Yet it's important to remember that these theories and models are not the final word. They are approximations, the best descriptions we have of nature within our current understanding. As our knowledge expands, these models are refined, or sometimes entirely new ones are formed. Theoretical physics, therefore, is an intellectual endeavor, a journey into the abstract. It's about asking, what if, and why not? It's about pushing the boundaries of our understanding, venturing into the unknown, and bringing back mathematical treasures to enrich our knowledge of the universe. It is, in essence, a quest for the fundamental truths of our reality. Now, let's leave the realm of abstraction and enter the world of tangible reality. Welcome to the vibrant sphere of experimental physics. Here, the theoretical musings of the mind are put to the test, and the abstract becomes observable. Experimental physics is where the rubber meets the road. It's about rolling up your sleeves and getting your hands dirty. It's about designing and conducting experiments to test theories and discover new phenomena. It's about the thrill of the chase, the pursuit of answers, the joy of discovery. While theoretical physics deals with the mathematical models and hypotheses that describe the universe, experimental physics is all about the practical application of those theories. It's about setting up experiments, collecting data, and analyzing results. It's about investigating the world around us in a systematic and scientific way. Consider the iconic experiment by Rutherford, who fired alpha particles at a thin sheet of gold. This experiment, simple in concept yet profound in outcome, revealed the nuclear structure of atoms. Or take the experiments at CERN, where cutting-edge technology enables scientists to smash particles together at near-light speeds, uncovering the fundamental building blocks of the universe. In experimental physics, the lab becomes a stage where the drama of the universe unfolds. It's where theories come alive, where hypotheses are tested, and where new phenomena are discovered. It's a world of trial and error, of unexpected results, and of revolutionary breakthroughs. But it's not just about validating theories. Experimental physics also plays a crucial role in discovering new phenomena that challenge existing theoretical frameworks. It's a field that keeps us on our toes, continually driving us to question, to explore, to push the boundaries of our understanding. Experimental physics, in contrast, is a journey of exploration and discovery in the real world. It's about grounding our understanding of the universe in empirical evidence. It's about the tangible, the observable, the measurable. It's about turning the abstract into the concrete, the theoretical into the practical. It's about making sense of the world around us, one experiment at a time. So, how do these two worlds of physics interact, you might ask? Well, the interplay between theoretical and experimental physics is much like a cosmic dance, an intricate ballet of hypotheses and trials, predictions and confirmations, questions and answers. It's a dynamic relationship that propels scientific discovery and understanding forward. In this dance, theoretical physics often takes the first step. Theoretical physicists, with their abstract equations and models, paint a picture of what could be. They project an image of the universe, drawn from the depths of human imagination and understanding. It's a realm of possibilities, a cosmos of what-ifs. Yet, these what-ifs are not idle musings. They are the seeds of scientific inquiry, the sparks that ignite the flame of experimental investigation. And so the dance continues as experimental physics moves in response. Experimental physicists take these theoretical ideas, these possibilities, and they put them to the test. In meticulously designed experiments, they probe, they measure, they observe. They seek to see whether the universe as it is aligns with the universe as it's been imagined. And the universe answers. Sometimes it confirms the theories, whispering, "Yes, this is how I am." At other times it refutes them, declaring, "No, this is not my nature." And it's in this dialogue, this back and forth between theory and experiment, that our understanding of the universe evolves. Each confirmation solidifies our grasp of the cosmos, while each refutation compels us to revise our theories, to look again, to think again, to imagine again. It's an ongoing conversation, a perpetual pursuit of truth. It's a dance that never truly ends, for with every step, with every turn, new questions arise, new possibilities emerge, and the dance continues. It's a dance that's as vast and as varied as the universe itself. This dynamic interplay between theory and experiment is the engine that drives progress in physics. It's a testament to human curiosity, to our unyielding desire to understand the world around us. And as long as there are questions to ask, as long as there are mysteries to unravel, this cosmic dance will continue. But it's not always a smooth journey. As we delve deeper into the realms of theoretical and experimental physics, we encounter numerous challenges. Theoretical physicists often grapple with the task of translating complex, abstract ideas into mathematical language. They strive to craft models that are both mathematically rigorous and physically plausible, a challenging balancing act. On the other hand, experimental physicists face their own set of hurdles. Designing and executing experiments that can accurately test theoretical predictions is no easy task, especially when it comes to theories about phenomena that are incredibly small, like quantum particles, or incredibly large and distant, like black holes and dark matter. The practical constraints of technology, resources, and even our current understanding of physics can pose significant challenges. Unexpected experimental findings can also throw a wrench into the works, challenging existing theories and forcing physicists to rethink their assumptions. Remember the neutrinos that were initially reported to travel faster than light? That finding, though later attributed to a measurement error, sent shockwaves through the physics community, prompting a flurry of theoretical re-evaluations. And yet, it's these very challenges that drive progress in physics. They push theoretical physicists to sharpen their models, to refine their mathematical tools, and to venture into new, unexplored territories of the universe. They drive experimental physicists to innovate, to develop new technologies and methodologies for probing the physical world. Moreover, these challenges foster collaboration. Theoretical and experimental physicists work hand in hand, their efforts intertwined in a dance of discovery. Theorists provide the concepts and predictions that guide experimental design, while experimentalists provide the data that validates, refutes, or refines theoretical models. Despite these challenges, the collaboration between theoretical and experimental physicists is critical for advancing our understanding of the universe. Their combined efforts are the driving force behind our ever-evolving knowledge of the cosmos, propelling us further on this grand adventure of discovery. So, as we navigate the vast expanse of the universe, let's remember that the journey is just as important as the destination. As we conclude our journey, let's appreciate the intricate dance between theoretical and experimental physics. These two pillars of the scientific endeavor, while distinct, are intimately connected, each contributing to our understanding of the universe in its unique way. Theoretical physics, with its elegant equations and abstract models, provides the conceptual framework that describes the universe's underlying principles. It's the realm of imagination, where scientists like Albert Einstein and Richard Feynman have envisioned the curvature of space-time and diagrammed particle interactions. Experimental physics, on the other hand, is the tangible counterpart. It takes these abstract concepts and tests them against the concrete reality of our universe. From Galileo's inclined planes to the Large Hadron Collider, experiments breathe life into theories, providing the empirical evidence that either supports or refutes them. This dynamic interplay between theory and experiment is at the heart of scientific discovery. Challenges arise certainly, with theories sometimes posing experimental conundrums and unexpected experimental results, shaking up established theoretical frameworks. Yet, it's precisely in these moments of tension that science evolves, pushing the boundaries of our knowledge further. Remember, the universe is a book written in a language of physics. Theoretical physics provides the grammar, and experimental physics reads the sentences. Together, they help us understand the story of the universe,